We are picking up on example 3 for lesson 5. We are talking about word problems that have to do with exponential equations. Okay, so we're on example 3. It says strontium has a half-life of 25 years. If there are 225 GM now, how much will remain after 100 years? So we're given a couple pieces of information in this problem that are very important to solving the question. So given our general formula that's listed right here, we can place a few things in. So for example, the first thing I recognize is I try and see what kind of situation am I dealing with? Is there a percent increase, a percent decrease, half-life, or maybe doubling time? And I see right away that it's half-life. So that tells me that G, my growth rate here, is going to be equal to 0.5 or 1/2, so half. Okay, and that happens in 25 years. So this 25 years, that is going to be my D, which stands for my doubling time. Or maybe not doubling time. It's not always the best formula, but it means your cycle time. So you're talking about how long does it take for it to go down by half. And in this case, it's 25 years. Okay, so now a couple other important things. N naught, that's going to be your initial. So we're told that it initially starts with 225. And then T and N of T are usually the two things that we're solving for. So you're going to be given one of those pieces of information, in this case the 100 years, and you're going to sub that into your equation with the rest of the other things. So we're trying to find N of T. We know N naught is 225. My growth rate is 0.5, and then to the power of 100, which is my time, over 25. Now when you put this into your calculator, a couple things that are important. Make sure you put a bracket around your exponent. Other than that, this one's fairly straightforward. There's no rounding or anything like that. So go ahead and type that in. Okay, so the answer there is 14.06 GM. For questions like this, it didn't tell us where to round to, so make sure, if it does ask you, make sure you're careful with your rounding. Okay, next one, it says, when will there be 10 GM left? So I know it's going to be close to that 100 years, because at the 100 years there's 14.06, but in this case I'm looking for T. T is my unknown. So when I sub it into my equation, I get 10 equals 225 times 0.5 to the power of T over 25. Now, as of now, when you have an unknown in your exponent, that means that we're going to use the graphing method to find out. So on your left-hand side, you put y1, right-hand side, you put y2, and you graph it, and you find the intersection. Okay, so when I did that, I had to adjust my window settings a little bit, but I found my x value to be 112.3 years in order for there to be 10 GM left. So make sure you're comfortable dealing with your window settings. All right, next example. A population of fish decreases by 7% per year. If there are 2,500 fish in the pond now, how many will there be in 5 years? So we need to make an equation with the information that I'm given. So I always like to start with an equal sign, and then I place in my initial population. So in this case, my initial population is 2,500. Then I look to see what my growth rate is. I notice the word decrease and 7%, which means I need to take 1 and subtract 7%, which is 0.07, to get my B, my growth rate. So 1 minus 0.07 is 0.93, and that is what is going to go in the brackets here. If there is no doubling rate or tripling rate or half-life, then I don't need to include. The only thing that I need up top is t. But in this case, I know my t. My t is 5 years. So I'm going to erase that and I'm going to put in 5, and then that means I'm trying to find my y over here, which is how many fish there are in 5 years. Okay, so I go ahead and I type that in my calculator, and I get my answer as in 5 years there are 1,739 fish in the pond, making sure that I put units. Okay, next one. When will the population reach 100? I'm going to be using that same formula. However, now I know my final amount. I know that this is 100 equals 2,500 times 0.93, and I'm trying to solve for t. So I put this in for y1, this in for y2, and I find the intersection. When I find the intersection, I find it to be 44.35. So that means it'll take 44.4 years in order for the population to be down to 100 fish. All right, last example. The value of a certain house increased from 230,000 to 310 over a 5-year period. What was the rate of growth? So if you think about our formula that we have come up with, we're no longer given G, but that's going to be what we solve for. So my initial amount was 230,000, so that's going to go here for n naught. Then in my brackets is going to be my unknown, and it's over a 5-year period. And then over here, we'll have my final amount, 310. Okay, so one more zero there. So this one I'm going to solve algebraically. 23, divide both sides by 2300. Oh, I'm missing a zero on that one too. Careful with your zeros, 230,000. So I take 310 and I divide it by 230,000. And I get 1.3. I'm going to keep quite a few decimal places, 3.478 equals g to the 5. So we learned at the beginning of the unit that in order to get rid of the exponent, you raise it to the power of the reciprocal exponent. So I'm going to raise both sides to the power of 1 over 5. Carefully on my calculator. And I get g equals 1.06. So is what that means is the rate of growth is 6% increase per year. All right, go ahead and work on lesson 5 worksheet.